If you're already using things like Puppet or Chef or some things to help automate the process, it's better. But anything that's in the way of frequent releases is what's slowing you down. So this is something that we see that most companies just aren't releasing that often. You can see here the average is once a quarter. So the number of companies that are able to release new software into production daily, weekly, multiple times a day is still very small. So we still have a long way to go. And the way we do that is treating operations like a platform. The same way that a cloud provider does or anything like that. And the way they do that is treating it like a product. So you have product managers, your contracts of how you're going to provide support, all those types of things have to be well thought out. Treating the developers like users. And we do that by breaking kind of what we think of as operations into multiple pieces. So obviously we have our apps at the top that our developers are developing, but then taking operations and sort of splitting it between the traditional infrastructure operations, virtual machines and backups and all that kind of stuff, the infrastructure, and having an app platform team that can keep this platform running to provide these services to the developers in a way that's easy for them to use and can make changes very quickly. And just like microservice and application teams built around it, you do the same thing because, again, your platform is an application, is a product, is you have product teams around it. So people focus, if you have really small teams, obviously there's less people, but people focus on the thing from beginning to end. So if it's your CI/CD solution, they're deciding what they're going to offer, how they're going to do it, meeting with users, all those types of things. And really what we want to do is have a nice paved road for our users to run on. So not forcing them to use the platform, but making it what they would obviously choose if they would go on a nice paved road or drive through the woods. So we want to make it nice and easy for them. And really what we're trying to do is go from code at one end into production at the other. So it's a pipeline of code. So that way the developers can just commit their code and have all those pieces happen in an automated fashion. So this is what cloud native operations looks like. Like I mentioned, Netflix and Google and pretty much any high functioning software team that we think of when we think of these types of things, this is how they operate. We want to talk about this as open source cloud native operations. So there's tons of tools we can go buy to do those things, but what can we do with open source software to be able to build that pipeline? So what pieces are in a pipeline? What does a pipeline look like if we're building a platform to provide it? We can combine a bunch of open source tools. As mentioned earlier, Kubernetes. We have a Kubernetes workshop this afternoon. It's a very popular platform to run your applications and your pipeline, and then using a number of other open source tools. These are just a small sample. There's a whole bunch of others that you could use either in place or in addition to these. And then looking at it overall from using a thing called GitOps to do that, and we'll go into more what that is. So let's start with Kubernetes, since it's very popular and a topic that people have a lot of interest in. The real secret to Kubernetes is its controller. So under the covers, what's really happening inside Kubernetes is there's a bunch of things called controllers, and they're very small and do an individual thing. So it's a controller to just keep a container running. There's a controller to make sure there's the right number of versions of that container and all those types of things. So controllers are really what make Kubernetes great, not just the built-in ones, but you can also build your own and add them into Kubernetes to do a whole bunch of things. This is really what it is, though. What is a controller? It's really a state loop. So what you're saying is it's just constantly checking what's the actual state of my environment and what do you have in the configurations, the desired state, and if they're different, fix it, and just constantly check. So it's looking for this should have 2 containers. If for whatever reason there's 1, it'll create another one. If for whatever reason there's 3, it'll kill 1. It just wants to always make sure they're in the same state as you asked for. So each of those controllers does this in its own little loop. So Kubernetes is a whole bunch of these controllers. It follows the Unix philosophy of do one thing and do it well. So like I said, each of those controllers has its own one thing that it worries about. And really what we're seeing with Kubernetes is, we even hear it called like the Kubernetes dial tone, is this is sort of like the baseline that a lot of companies can then build their operations and applications on top of, because it's well understood. Where if you go to a cloud provider, even some stuff you may run in your own data center, there's different APIs, there's even different concepts. So even between cloud providers, how Microsoft Azure looks at networking and how AWS does, they have different concepts and things like that. So they don't always translate over cleanly. So what we see is people using Kubernetes as that sort of dial tone, and especially in operations, because everything's API driven, and we can use that to provide the rest of our platform. And the reason is too is, as I mentioned, it's that state engine is Kubernetes is declarative. So we don't say please start 4 versions of my application. You just say this application should have 4 versions, and Kubernetes is constantly checking to make sure it's that way. So the real advantage of that versus what we could call imperative, say like, hey, please start 4 instances. If I say that every time I issue that command, please start 4 instances, I'm getting 4 more. Whereas with declarative, I can keep saying I want 4, I want 4, I want 4, and you're always going to have 4. It's not going to deploy a whole bunch of them. So that's really at the core of building this model, is having things be very declarative. So we can set them and then have the infrastructure adjust to match that. And that's really important when we get to GitOps. So if you're not familiar with GitOps, it's a concept came from a company called Weaveworks. It's how they do things, and they published a blog post a couple years ago about it. But basically, they're using Git. So all of their configurations, everything is stored in a Git repo. So that's what they call their single source of truth, and they use it to operate almost anything. So if they want to make a change, just like you would with software, they do a pull request, reviews, all those types of things. Just like you can roll back a commit, you can also roll back your infrastructure that way. So again, it's back to that desired state, actual state. So you're changing your desired state in Git, and then your pipeline is adjusting your infrastructure to match that. So all the resources and deployments in Kubernetes is declarative, so that's kept in the Git repo. How many nodes do I have? How many clusters do I have? That type of stuff. And it's all in a single Git repo. So whether it's your configuration for other things running on top of Kubernetes, your Kubernetes configuration, all that stuff is in that single Git repo. And then changes are made by pull requests. So you can see who wants to make the change. You can set up however many reviews, all of your testing. So you even do CI on your platform itself. Using diff tools to look for that, like Kubernetes does that naturally, but some of your things that don't constantly check for state, you can use tools to make sure that the two are in sync. And same thing with rollback and audit log. So who made this change to the infrastructure? Who opened this port? Who installed this application? All that stuff is kept in Git. So let's run Kubernetes. Kelsey Hightower from Google, this is a tweet of his, I think it was a couple years ago, that Kubernetes by itself isn't a platform. It's a platform for building platforms. Same thing, Joe Beda, who was one of the Kubernetes founders when he was at Google, same thing. It's a platform, so we use that to build our platforms. So what we often hear is, well, developers won't like using Kubernetes and YAML and these types of things. And it's like, well, they're not supposed to. This is where that platform team we talked about, your operations as a product, they're operating that, and the developers, it should seem pretty seamless. But the way we do that is we still need more stuff on top, right? So first thing I want to start with is keep the idea of having many smaller clusters. So you can always combine them later or change how you do them, but you don't need to start with like set of 5 clusters to start, but have that in your mind as you're building things is, once I set this cluster up, I'm going to have to do this a bunch of times, so I should have a way to do that in a declarative and automated fashion. So the real big advantage of doing one big cluster, doing many small clusters, there's a really good blog post by an engineer who used to work at Target, they run a lot of Kubernetes and a lot of clusters. They had one process go kind of sideways, and it took down all the resources of one of their Kubernetes clusters, but that cluster was only operating one part of one of their production apps. So the rest of their environment was up and running. So the idea is, if they're computers, it's software, it's all terrible, so it's going to break at some point in some way you didn't foresee. So limiting sort of the blast radius of your problems or errors is the main reason we see people do a lot of small clusters. So again, going back to that pipeline, let's build our pipeline, the pieces that we started talking about before. So you can get Kubernetes anywhere. So you can download it, Minikube. All the bits are online. I work for Pivotal. We have a version of Kubernetes. All the public clouds have them available. You can get VMs from the clouds and install Kubernetes and run on your laptop, whatever you want. But we're going to start with with a Kubernetes as the destination where we're going to run our apps. So we have a platform. We also then need a place to store our artifacts, our images. So the open source Harbor registry, we'll use that here. And the advantage of Harbor is it does scanning. So it can scan your container images. So if you're building container images, your developers, and there's some new CVE, it'll scan all your containers and find them and alert you, or however you want to handle it. There's a lot of different ways. It also can replicate. So if you have multiple data centers and you want to replicate your container images, Harbor can do that. Git, right? We need some way, whether you use GitHub online or GitLab or GitHub Enterprise or any. Basically, you need that Git version control system to not just have a place for your developers to put their apps and do their version control, but also you having one for the platform itself, as we talked about. So that way we can talk to the platform in a declarative manner. CI. So we're going to need to test. And for our developers, a way for them to run all their tests. We'll talk Concourse, which is open source, but there's also Jenkins and others, and then there's services like Circle and Travis. And then a deployment tool. So Spinnaker is a very popular deployment tool, and we'll talk a little bit more about that and how that works, but it is open source as well. So once we have this as sort of our cluster environment, this is what we're going to provide to our developers. We still need additional stuff. So we're going to probably want some monitoring and logging support. So we can use Elastic for our logs, and Grafana for dashboards, and Prometheus for monitoring. So we're going to want to have that on our cluster so we can see if apps are having performance problems or there's errors like what we can see in the logs. We're going to want all this. But remember, we talked about multiple clusters, many clusters. So now we have to install all this software each time we set up a cluster. So we definitely want to have a automated declarative way to do that when we're setting up our clusters. So we've spent a lot of time trying to figure this out. The community as a whole, DevOps, more recently SRE, systems reliability engineering, the concepts of teams working through the whole platform from installing operations, the whole lifecycle of the platform as a team. We figured this out pretty decently. We just have to, in some cases, do it. So one of the tools I mentioned earlier, Helm. Helm is a tool for templating Kubernetes installation. So Kubernetes has manifest. That's how you tell it what to run against declarative. So you just say, this is the stuff that should be here. And it doesn't matter how many times you apply that manifest, as long as it's the same, nothing changes. So Helm lets you create templates of manifest. And the reason you would want to do that is the manifest is detailed. It's going to say what this application's called, what ports it's on, what container image it's using, all of those things. Well, if I'm going to install it a whole bunch of times, I'm going to want a templated version. So Helm allows you to template applications and then apply them to Kubernetes. So again, going back to our platform operations concept where we have all these different clusters, I can have a repo of Helm charts that install Prometheus, Grafana, Concourse, Harbor, all the different pieces we want for a cluster. We can have one chart repository with all of those charts configured the way we want them configured in our environment, whether it's highly available or what have you. And then we have a repo for the actual settings for that individual cluster. So the first cluster's Helm chart settings, what the name of the cluster is, all those types of things. So that way they can use those, basically they get merged together by whatever tool you're using to apply it with Helm. So you can use your CI tool is pretty common, like this is showing Jenkins here. And another project I work on, we do it exactly that way, where you have your Git repo with your configurations for that cluster. Again, we issue a pull request, and that kicks off a process that runs Helm in a CI job to apply those changes that we made. So the nice thing is, you need to stand up a new cluster, you can just clone one of those repositories, make the configuration changes you need for your new cluster, and then run it, and now you're going to have it. And that way you may have, we have customers that are running as many as 60, 70 different Kubernetes clusters. So that can get out of hand really quickly if you're trying to set all these up, all these little tools and manage them manually. And once we have these clusters set up, what we want to do is provide this workflow for the developer. So that way, they have their source code, they have their repos for the stuff they're working on, and that way we can plug it into all this tooling, and that way they don't have to do anything besides commit code, and it will run all the CI tests, create the container images, and then actually deploy the app instances with Spinnaker. And one thing you may have just noticed, I talked about Spinnaker to deploy. Here when we're talking about applications, but here I talked about Helm. So Helm charts are really great for describing configurations around an application and how it should look like when it's deployed, so how many nodes it needs and all those types of things. So it's really great for, well, I wouldn't call it prepackaged, but pre-built applications that you're deploying, like Prometheus. You're just pulling it down from the internet and installing it. So Helm is really great describing those things. But if you're making constant code changes, you may need something more, more advanced to deploy that for your actual application. So, looking for different ways of doing things. So we'll talk about Spinnaker now, about what Spinnaker brings above something like Helm. And that's what we see. That's sort of the split we see too. Is the people managing and operating the platform use Helm to deploy, the platform and its apps. And the actual developers we're using Spinnaker to deploy their production applications. So most people don't have this problem, but this is Netflix's problem. Tons of microservices, tons of applications. Each application is made of thousands of microservices. Each of those microservices are made up of a bunch of individual containers and nodes. So this is this is something that Netflix deals with on a regular basis. So they've always built a lot of their own tools. So and they open source them, which is great. So they used to have a tool called Asgard that they use for deployments. So they created Spinnaker specifically to handle that use case. But typical of Netflix, they needed it for themselves. So they created it to talk to the things they use, like AWS, which then what we see more commonly is customers, they have a lot of different stuff. So like, well, we have VMware, we want to use Kubernetes, and maybe we have some OpenStack. So that's where the community came in. So that's the advantage of Netflix open sourcing everything, is let's the community get involved and contribute. So the community has added the ability for Spinnaker to talk to all these different environments and multiples of them. So you could have a single Spinnaker interface that's deploying to multiple Kubernetes clusters and multiple clouds, also to VMs, also to OpenStack, what have you. And to give you an idea right now, I think Google has something like 14 full-time engineers just contributing to Spinnaker right now. Pivotal, we have a number of engineers contributing to it as well. It's a really popular application deployment open source project. So especially when you put it together with Kubernetes, we get all the advantages of the declarative nature of Kubernetes, running things in containers, and then the ease of deployment of Spinnaker. So Spinnaker, there's kind of two halves to Spinnaker. The cluster management side. So this is basically what's my inventory. So one of the questions I get is, well, why don't I just use Jenkins to do deploys, or why don't I just use Concourse or whatever? And the main reason is state. So if when you start a Jenkins job, it has no concept of state. It's going to have to, if you're saying to go do something to a live running environment, the first step will have to be go see what the current state of that environment is. And then, if it doesn't match what I'm expecting, stop or something like that. And when the job is done, you have a record, a log of that job. But it's sort of a very standalone one-time job, which is perfect for doing CI testing. But when you're doing delivery, every one of those deploys is a touch of production, so we want to keep track of those artifacts. So the first half is it's constantly looking at your environment, what's here. So if someone made a change outside of Spinnaker, it knows about it because it finds it on the, say if someone changes a pod setting or whatever, it'll see that. So the way it's organized is around server groups and clusters. This is Netflix picked this terminology, so we're stuck with it. It can be a little confusing because when it says a server group, it means of an application, and load balancers are really in the Kubernetes case are access to like services and ingress. May not necessarily be a load balancer. So the terminology can be a little bit confusing when you get in there because it doesn't exactly match to Kubernetes. But that's really when you go on the one side of the screen, you'll see here's everything I have. The other side of it is pipelines. So this is where we build those pipelines to say, what do we want to do from a deployment perspective? So if there's a code change, then what happens? So again, it's inventory on one side, and it's multi-cloud, which is key, so I can see every place I'm deploying this app to, and then actions and reactions. If this happens, do this. If this fails, roll back to this. All those types of things. So this is a very basic sort of pipeline idea. Find an image, deploy a canary, do some testing. If that works, deploy to prod. You can also do what they call manual judgment, which just basically is a button then you can push and say go ahead. But you can have all these steps, and they can get really complicated. You can do some really complex pipelines within Spinnaker to do a lot of different things. You can call out to a lot of other tools, so you could even use that to kick off your CI jobs. What's the most common configuration we see is the code commits kick off CI jobs to do integration testing, but once it's pushed as a completed release, and it kicks off a Spinnaker workflow, one of the CI jobs it'll call out will be to do something like security scans, code security scans or code performance analysis or things like that will be done, because at this point it's not does it work, it's like we want to push this to production, so we want to see, we may want to know a little bit more about that code. And it handles really advanced deployment strategy. So the very basic, of course, again, Netflix made it red-black instead of blue-green, but everyone knows it's blue-green, which is I stand up the new version, and then I just cut over the access to that one. So if there's anything wrong, I can just switch it back. Rolling red-black, which is stand up, add an instance on the new one, and take one down, and slowly do that. Is another way to do it. Canary is a pretty advanced way, but this is one of the ways you can use to make your changes into production more often. Because one of the challenges we see with complicated environments are there's so many different groups deploying different pieces. So if you're really doing microservices, so there's one group developing the web front end, there's one group developing the authorization piece, is if you're deploying quickly, it's hard to test because this version you're testing against of this one microservice may in production be newer. So it may work in test, but the production version is 2 versions newer. So it's really getting to testing in production, which sounds scary, but if you do it right and using things like canaries, you can do it in a pretty safe way. So basically canary is, it'll start rolling out versions and then running tests and comparing it. So it'll roll out a baseline version of the existing and then the canary, the new version. And as long as it's within what's expected tests, it just will keep adding new versions until it's cut over. And if it runs into a performance problem or anything else, it'll roll back to the previous version. So the way Spinnaker works is you as the user talk to the app, whether it's via the API or the GUI or what have you, and then it uses the cloud APIs to talk to the underlying infrastructure and see all the apps and everything like that. So this is what Spinnaker looks like, though. So it's Netflix, and they built it, so obviously there's tons of moving parts, and it's made with microservices in the very best microservice fashion. But if you're trying to deploy this for yourself, you may say, well, I only have 2 apps to deploy. I'm going to deploy a whole bunch of apps to deploy 2 apps. So this is where the Halyard comes in. So this is an open source project that the community put together because deploying Spinnaker was hard. And what it does is it automates the deployment of Spinnaker and configuration changes and those types of things. There's also a Helm chart for Halyard as well, Halyard and Spinnaker. So the Helm chart deploys Halyard, which then deploys Spinnaker. So and even once it's deployed, you can log into Halyard to make configuration changes and upgrade and all those types of things. So it took something that was really complicated and made it really easy to do. So overall, this is the key thing here is operations are what gets you into production. So if you're used to doing things you've started to do something in more of, say, a DevOps fashion or Agile fashion on your development side, you're probably doing it a little bit in test too. But the problem with that is getting it into production. So we can keep releasing versions, but if they can't upgrade to it in production, we're not any better. We have new versions sitting there that we can't deploy. So this is something that these companies have focused on to be able to get that code into production more often. So it's things like doing canaries and automating all these pieces for the software development team. So that way, there should be very limited things stopping a version from going into production. So that way, if it's, it may just be one check, that manual judgment. It may be, a bunch of tests running, but you don't want it to be where you're opening a ticket or, it has to go to some review board or something like that just to get a release, because all of your releases will back up. So it doesn't matter how quickly you develop the software if you can't get it into production. So the thing that we see customers doing successfully that are able to do this is they're doing with open source tooling, things like Spinnaker and Helm and all these pieces, and they're doing it in an automated fashion using things like GitOps. So thank you. And want to leave time for some questions?
Thank you for your great talk. So what about questions? Yeah, I see some hand. Well, it wasn't. It was hand of our operator. He was correcting the placement of the camera. OK. Any more questions? Well, if not, then thank you once again for your nice talk.